Good afternoon once again. The last topic that we have to discuss in Chapter 2 is the interrelationship of energy, matter, and ecosystem productivity. So productivity is our key word, and we're going to use a topic that we've already discussed a little bit, the idea of biomass. Primary productivity is defined as the rate of new biomass production. So if we're talking about how an ecosystem works, we would always be starting with plants. So we're going to focus on primary productivity. Primary productivity depends on solar energy. We know that plants require the sun for photosynthesis, so increased solar energy will lead to increased photosynthesis. If there is more photosynthesis, we will have higher productivity. In other words, we will be able to measure the biomass of plants, and that will help us determine how much photosynthesis occurred, and that will be our measure of productivity. So we are going to determine primary productivity by measuring the growth of plants in an area. The lab that we do is based on the HTA field. We can take the total plant material in a defined area. So obviously we're not going to take every plant that exists, we're going to take a sample. We'll remove it, dry it, and weigh it. And then we'll compare, and we could also compare between different ecosystems to determine which is more productive. If we can determine which is more productive, this would be our clue as to which one receives more energy. So this brings us back to Chapter 1, Biosphere, and how much energy each ecosystem receives. So down here I have a little chart which you do not have to memorize. I'm putting it here to help illustrate a point. There's a picture in your textbook that's very similar to this one. It shows a bunch of different ecosystems and how they compare if we talk simply about productivity. And so that picture in your textbook is on page 53. So you could refer there if you ever needed to have a specific example. The idea that I want you to recognize is that these ecosystems at the top that have high productivity are usually warm and humid. And as I move downwards towards ecosystems that have low productivity, they are usually the ones that are dry or cold, or both dry and cold. Now again, I don't need you to memorize details of specific biomes, specific ecosystems, but just to recognize the factors that would affect productivity. So obviously at the top here, I have my tropical rainforest. Things like swamps and marshes are usually very warm and very humid. Way down at the bottom, we have our desert, and we have our Arctic areas, because those areas tend to be not only dry but cold. Some of you might say, no, the desert is hot, but actually there can be hot and cold deserts. And even deserts that are hot, it's usually very cold at night. And then areas that are in the middle that have some amount of productivity vary in those conditions. They're not as warm and humid as, say, a tropical forest, but they're definitely not as dry and cold as the desert or as the tundra. So we're going to do a few comparisons to help illustrate how you could explain why one area has more productivity than the other. The first example is the rainforest compared to the desert. And we're going to talk about the hot desert here. The rainforest has tremendous productivity. So its productivity is very high. That means many plants are growing. The biomass of plants is increasing. It receives a ton of sunlight all year round. So if we compare that to here, we receive a ton of sunlight in the summer, but not all year round. If we combine that with precipitation and fast decomposition, plants grow very well. So we've highlighted a few of the factors that are necessary for productivity. Sun is definitely one, water is one, and so is the availability of nutrients. So if we determine the productivity of an area, it's not only going to be based on available solar energy, it's going to be based on these other factors as well. If we take the desert in contrast, deserts have a very low productivity. Why? Because of precipitation. They have lots of sun. Deserts receive usually a very comparable amount of sunlight to the rainforest, because if we're talking the hot desert, both of these areas would be found right near the equator. So the amount of sunlight they're getting isn't the thing that's distinctive, it's one of the other factors. In this case, precipitation, and as sort of a byproduct, decomposition. If there's not a lot of precipitation, then decomposition tends to be slow as well, because decomposition is faster when it's humid. Now we'll compare two other areas as well, the intertidal zone versus the deep sea. So over here on the picture, this is the deep sea, and this is intertidal. So basically we're talking about areas of the ocean that are close to the shore and areas that are farther away. The intertidal zone has high productivity compared to the deep sea, but in this case it has nothing at all to do with water. In both of these cases, water is available, and that's fairly evident because we're in the ocean or surrounded by water. So the difference here is sunlight. In the deep sea, there is a lack of sunlight, and so for the producers that do exist there, sun does not get to the bottom of the ocean where it's deep as easily as it does where it's shallow. The other thing, a lack of producers. So that's yet another factor that could affect productivity, the number of producers. So if we sum this up, we've highlighted a few factors: the sun, water, available nutrients, numbers of producers. All of those things will affect what the rate of productivity is. So we can't say it's only based on sunlight, but that's definitely a key factor because without the sun, we can't have photosynthesis.